Hello everyone, I welcome you all to this video tutorial, and this video tutorial let's go through sensor network protocol stack. So basically this is the stack that which is used for wireless sensor network protocol, and here it follows the OSI model layers, mainly physical layer, data link layer, network layer, transport layer and application layer, and along with these layers it also includes LSTM, where L stands for localization, S stands for synchronization, TM stands for topology management. And on the other side, it also contains PMT, where P corresponds to power management plane, M corresponds to mobility management plane, and T corresponds to task management plane. So this protocol stack combines power and routing awareness. It integrates data with the networking protocols and communicates power efficiently through the wireless medium and promotes cooperative efforts of sensor nodes. So basically this protocol stack is something that which combines power with that of routing awareness, and it integrates data with that of the networking protocol, and it communicates efficiently the power over an infrastructureless medium and promotes cooperative efforts of the sensor node. So now let's go through this protocol stack one by one. The protocol stack consists of physical layer, data link layer, network layer, transport layer and application layer, as well as synchronization plane, localization plane, topology management plane, power management plane, mobility management plane and task management plane. The physical layer addresses needs of simple but robust modulation, transmission and receiving technique. The network layer takes care of routing of data supplied by the transport layer. The transport layer helps to maintain the data flow if the sensor network application requires it. Power management plane manages how sensor node uses its power. Example, the sensor node may turn off its receiver after receiving a message from its neighbor. This is to avoid getting duplicated messages. The other example for power management is when the power levels of the sensor node are low, the sensor node broadcasts to its neighbor that it is low in power and cannot participate in routing messages. The next management plane is mobility management. It detects and registers the movement of sensor nodes, so a route back to the user is always maintained, and the sensor node can keep track of their neighbors. Task management plane balances the schedules and sensing tasks given to a specific region. Not all sensor nodes in the region are required to perform the sensing task at the same time. Physical layer. Physical layer is responsible for frequency selection, carrier frequency generation and signal detection, modulation and data encryption. So it is something that is responsible for frequency selection, generation, signal detection and modulation. Data link layer is responsible for multiplexing, frame detection and medium access control. So using this data link layer, we have this MAC as well as it also does the error control. And in error control we have three different kinds. One is forward error correction and automatic repeat request, and third one is hybrid. The drawback of ARQ is that additional retransmission costs as well as overheads are involved in it. Drawback of forward error correction is decoding complexity is greater in this. Then we have this network layer. Sensor nodes are scattered densely in a field. The information collected relating to the phenomena should be transmitted to the sink, which may be located far from the sensor field. Limited communication range of sensor network prevents direct communication between each sensor node with that of the sink node. Networking layer of sensor networks is usually designed according to the following principles. Let's see what all principles. Power efficiency, data centric, relay nodes can aggregate the data, and they all have no unique IDs, but rather they are addressed based on their attributes or based on their data and location. And the last principle is they should provide inter-networking with external network Sync nodes can be used as gateway to the other nodes. So these are all the principles on which network layer is actually built. So first one is power efficiency, followed by data centric sensor network. The third one is relay should aggregate the data, and the third one is they are all they don't have any unique IDs, but rather they are addressed based on their attributes or the data collected or location, and provide internetworking with external networks. And sync can be used as the block that which interconnects two or more different networks. Then we have transport layer. So transport layer is especially needed when the network is planned to access through the internet. So when we want to access the network via the internet, we need these transport layers, and specifically we have two different protocols here, TCP and UDP, and mostly we make use of this UDP protocols because TCP had larger overhead because of larger header size compared to that of the UDP. UDPs are connection-less oriented, but whereas TCPs are connection oriented. Then finally we have application layer. So this actually maintains the application, as well as if there is any query, it does the query processing and network management. The application layer includes main application as well as several management functionalities, query processing and network management. Layered architecture stack has been initially adopted, but larger scale implementation of wireless sensor network application reveal that wireless channel has significant impact on the higher level protocols. So even though layered architecture stack is adopted, but here later it came out to know that the main component, that which is wireless channel, has significant impact on the higher layer protocols. Resource constraints and application specific nature of wireless sensor network model leads them to cross-layer solutions. Wireless sensor network should be able to correctly order the events sensed by the distributed sensors. Timing requirement have led to the development of time synchronization protocols in wireless sensor network. Location-based services require position information, that which has led to the formation of location protocols, and several topology management solutions are required to maintain the connectivity and coverage of sensor network. So this is about this wireless sensor network protocol stack. So in the last, right after this application layer, all you got to explain is the different topics that which are involved in the syllabus. That is, we have this localization, as well as we have this timing synchronization, and finally topology management. And in our next tutorial, let's go through the applications of wireless sensor networks, and specifically we'll be into environmental application, that is early flood detection.